Introduction to Aerodynamic Objects Tutorial 8 Flight Control. And in this tutorial you're going to link player inputs to aerodynamic objects to control your aircraft. And our objectives are to use player inputs to control the camber of aerodynamic objects. Then we're going to use a simulated wind tunnel experiment to verify control response, and then we're going to adjust aircraft properties to achieve our desired flight handling characteristics. Here we are in Unity, and as usual we're starting tutorial 8 at the end point of tutorial 7, so I've taken that scene and resaved it as tutorial 8. And what we're going to do first is change the aircraft manager on the aircraft to the tutorial 8 version. So let's do that. So let's get rid of the tutorial 7 version and add aircraft manager tutorial 8. Okay, let's wire this up. So some of the things we've done before, we've got our center of mass marker and we've got our propeller hub, so we've done that before. But now what you'll see on here, we're asking for some aero objects, so the port wing aero object, starboard wing aero object, and so on. And by varying the camber of these aero objects, we're going to use that to control the aircraft in flight. So let's get these connected up. I'm going to do Alt-click on aircraft to open up everything because the aero objects are at the bottom of the hierarchy, and we need the port wing, so wings, starboard wing, port wing, aero object, drag that in, starboard wing, aero object, drag that in, horizontal stabilizer, drag that in, vertical stabilizer, drag that in. Okay, we've got some control gains here. We don't really know what we need for these, so let's just type 1 in to get things started. But with the RPM, I know 100 is a good place to start on that. Okay, so that's how we're going to control the aircraft in terms of changing the aerodynamics, but we need to communicate with the Unity input system. So what we're going to do is add a Unity player input component. And we need to connect that up with some pre-prepared input mappings, which I've already made. So if you click on the target icon, you may have to navigate to find this, but the one we're looking for is AO tutorial user inputs, and just select that. And we don't have to worry about anything else in there. Okay, so far so good. I did say these tutorials weren't going to have any coding in, but I think it's important to show how the user input is adjusting the aerodynamics to get the control. So we're just going to show a couple of lines of code. So here we are in the script aircraft manager tutorial 8, which we added to our aircraft game object. And the important thing here, if we look on line 12, here are our aero objects that we connected up. So port wing, starboard wing, horizontal stabilizer, vertical stabilizer. And then the really important bit from the aerodynamics point of view, this is where we convert the player input into an aerodynamic change on the aircraft. So line 45, roll input, we're getting our roll action, reading the roll action, and then on line 46, here's the port wing aerodynamic object, and we're changing the control camber of that object by the roll input multiplied by the roll control gain. And since it's a 2 wings involved, do the same thing for the starboard wing for roll, and then so on for pitch, where we get the pitch input, and then the control camber of the horizontal stabilizer is modified by the pitch input multiplied by the pitch control gain, and similarly down to the yaw input and controlling the camber of the vertical stabilizer. Okay, so what we could do is just fire the engine up and go and see if it flies, but actually what you find is that it's far more instructive to test these things in a kind of virtual wind tunnel setup, a bit like what we did with the weather vane, where you pin the center of gravity and you can see what's going on. So that's what we're going to do now. So first off, if we're on the aircraft, if we want to pin it, we can just freeze all the positions there and it's not going to move, but the arrows will tell us what the aerodynamic forces are going to do. Let's put the aircraft somewhere sensible. So what I'm going to do is, well, I'm just going to zero this position, and I'm going to set it at 5 meters. We need to set up a wind flow field for our mini wind tunnel, and what we're going to do is re-enable the wind field that was left over in the scene. If you haven't got yours there anymore, you can easily just create another one. We're just going to reuse the one that was there. with some changes. First thing, that previous one was a massive one, so it was 200 meters wide. Let's just make that 1, and what that means is our fluid zones, they're set at location of 0, but they're 10 meters wide, so it's a box 10 meters by 10 meters, and our flow field arrows, same, located at 0, 0, 10 by 10 meter box. But we don't need so many arrows because it's much smaller. Let's have it 3 by 3 by 3, and let's make our arrows a bit smaller and slightly less sensitive. And I'm going to bring the visual range down to just a bit smaller so it focuses on our plane. The rest of it is all set up. We've previously established the fluid zone as our target to where we're getting our velocity information from. So let me look at that. Okay, that's okay, but it's our plane sitting on top of it, so what we need to do is lift it up. So if it's 10 meters, if we lift it up 5 meters, that'll center it on our aircraft. Okay, so that's looking promising. We've got our box of wind. Default conditions are that the wind should blow from the north, so from Z, so it'll blow that way. Our plane's fixed in space. Let's give it a go. Okay, there's our plane. It's got some wind blowing on it. So let's see what the controls do. If I pull back on the stick, so the down arrow, we get a force going down. If I push forward, we get a force going up, which is good. If I do right arrow, that's going to roll to the right. And if I do left arrow, it's going to roll to the left. But those changes in forces are massive. So what we're doing there is making very, very large changes to the aerodynamics. So what that's telling me is our control gain is much too high. So what I'm going to do is reduce these down from our initial guesses to something much smaller. Let's change it to 0.2. And people say you can never have too much control, but that's a lie. If you have too much control, you can't control your aircraft because it's all over the place. You put a tiny input in and it makes a massive difference. Let's try that again. So we're from the behind, it's probably the easiest place to look at it. So I'm going to do left arrow. So there's more lift on the right hand side than the left, so the aircraft is going to bank with the right hand wing or the starboard wing going up, so that's right. And if I play the right arrow, it does the opposite thing happens. So what's happening here, we've got wind blowing on our surfaces. As the aircraft stands there, it's not actually generating lift, but it's just a little bit of a drag. But when we're changing the camber of the surface by doing the control inputs, that changes our aerodynamic forces. And that's the basis of how flight controls work. Whether it's flaps or anything else, what you're effectively doing is changing the camber of the surface. So elevator, pulling back on the stick, we're getting a down force on the tail. That's pushing the tail down, pushing the nose up, that's right, and the aircraft will try and climb. So arrow forward, a positive force on the tail, lifting it up, nose goes down. And then finally rudder, so that's A and D. So if I want to turn left, I'm going to hit the A key. But then what happens there, we're getting a lift force to the left on the fin. And in fact, if we look at that, what that's going to do is pull the fin to the left, so the nose is going to go to the right. So it's actually the wrong way around. And so D does the opposite. So I want to turn right, but it's pulling the fin to the right and the nose is going to the left. So that's the wrong way around. So what I need to do to correct that is change the sign of the yaw control. And it's quite common when you're setting up aircraft that you have to change both the magnitude and the sign of the control gains to get the behavior that you want. So you change the magnitude to change how big the control response is going to be, and you change the sign to get the direction. What do you want it to be? Our last term on here, which we haven't fiddled with, is the control responsiveness. So this changes how quickly the controls move when you apply the control input. So 1 is probably a bit sluggish. If I change that to 2, and what that means now is when I control input, basically it's like the control surface is moving more quickly, so you get the full magnitude of the control more quickly. And this is down to your pilot handling, how you want the aircraft to respond to your controls. Okay, that's good. So we've set up our aircraft. The controls have about the right effect and they're in the right direction. Now let's see what happens in terms of the dynamics of the aircraft. Does the aircraft respond in the way that we would expect? And to do that, what we're going to do is just free up the gimbal, so we're going to free it up in rotation, and then let's see what happens. Okay, so immediately what you see there is the aircraft, as soon as we let it go, is actually gone to a positive angle of attack, and that's because we have this setting on the tail plane with the leading edge down. What that means is it's effectively pushing on the tail down, so this thing balances as a positive angle of attack, and that looks quite happy in the sense it's got lift on, and there's no control inputs, but it's got some positive lift on each of the wings, so that means it'd be quite happy flying. So let's try putting in our roll input. So I'm going to do roll left, and that makes it roll left as required. Roll right, roll banks right. That's good. If you look at the green arrows, there's quite a lot of different things going on there, and I think to remember, when an aircraft is moving dynamically, you've got damping forces on the wings as well, so the lift depends not only on the camber of the surface, but when it starts rotating round, that changes the angle of attack of the wing as well, and that introduces damping. So you can see it's reasonably complicated depending on what the aircraft is doing, whether it's accelerating or not. We do the same thing for elevator, so we're looking at it sideways on, pull back on the stick, so that's now balancing at a high angle of attack, which is what we'd expect, and push the stick forward, so there's basically an up force on the tail, and that's us trimming at a negative angle of attack. Finally, if we do yaw, I'm going to do A for yaw left, so notice that's the right way around now, so the nose is swinging left, and if I do D, we want to yaw right, and the nose is swinging to the right. We can put the throttle on at this stage. It shouldn't actually make any difference to the trim of the aircraft because we've got the thrust line aligned with the centre of gravity, so the thrust of the propeller is pretty much going straight through the centre of gravity, so there's no pitching moment from the propeller. In many aircraft configurations where the propeller is not lined exactly with the centre of gravity, when you turn the propeller on you get a change in pitch. So there's often quite a lot of work setting up the thrust line of the engine so that it has the behaviour you want. Fantastic, so we've got our aircraft flying on the gimbal satisfactorily. We've got our control gains set as they should do, so that means we're now ready for test flying. Okay, so let's get this aircraft ready for flight testing. The first thing we're going to do is put in a runway. So we don't need this, but it kind of helps visually tying everything together. So if you go to prefabs and find runway, you can drag that in. And let's get our Aeroman figure at the start of the runway slightly out of the way. That's good. And our aircraft, let's bring it down so it's touching the runway or just above it. And since we're doing flight control, we've not got an autopilot on board, so really we need somebody to fly the plane. And as it happens, Aeroman's got a brother, and if you go into prefabs you'll find pilot sitting, and if you drag that in and drop it on top of the aircraft, sitting Aeroman is there, and if you lift him up he can sit on the CG as a bit of a cushion. And this guy does nothing from a physics perspective. He's got no mass and no drag, so he's purely there for visuals, but it's kind of fun to see a guy trying to fly the plane. And what we're going to do is drag the plane to the start of the runway, so give it a fighting chance for taking off. And then just while we're here, some other things that we didn't do before. If we go to the tail and if we open that up and go on the geometry of those two, when we built this before we didn't have the box gliders enabled, just because we can, so stop the tail going through the floor. If we hit the floor with the tail, we're going to click enable the box colliders on that. We've got the script controlling the CG now, so it doesn't matter what other colliders we include with the rigid body. Okay, that's good. What else do we need to do? We need to set up our cameras. So our ground camera, if we're filming the flight test, is over there. It's going to point towards the plane once it starts because its target is the aircraft. We set that up before. The aerial orbit camera is the one we've used in the past, and that's still set up good. And then we've got the aerial chase camera, and this one is a camera where the angle of the camera is fixed relative to the aircraft. So if we start it off behind the aircraft, what it'll do, it'll carry on pointing in the forward direction of the aircraft, so we can use it a little bit like a first-person view camera. But we need a target for that, so we're going to drag in the aircraft target for that, and we're going to start off with it in a sensible place just behind the aircraft. And our cameras are set up on F1, F2 and F3. So F1 is our ground camera, F2 is our orbital camera, and F3 is our chase camera. What else? Because we're test flying, we want a nice still day. So if we go to wind, and in fact let's turn the whole thing off, so we haven't got wind to deal with. At the moment it's only a bit of wind in the box in the middle, so that wouldn't be right anyway. One really last important thing we need to do is set up the physics time step for this simulation. So because we're simulating things that are moving relatively quickly, what we're going to do is reduce the fixed time step that Unity uses for integrating up its physics. And what that does is basically just gives us a higher fidelity physics model, in the sense we're calculating the physics at a much smaller interval, so any errors that are accumulating are much smaller. So to do that, we're going to go to Edit, Project Settings, and then find Time on there, and this is what we want to vary. So the default in Unity is a fixed time step of 0.02 seconds, so that's updating 50 times a second. What we're going to do is actually decrease that by a factor of 10, so we're actually going to be updating at 500 times a second. So this is a conservatively small value, but best practice is that you start with a small time step and sort out all the issues with the model, and as you get confident with the physics you can then start decreasing it. However, if you make this time step too large, you start getting time artifacts in the simulation where, for example, the propeller goes around too far in one time step and it doesn't calculate the forces correctly. But something to experiment with there. And finally, there's one job which we need to do, which I forgot to do, and that is to unlock the center of gravity. So when we had it before, we unfroze the rotation. We now have to unfreeze the position as well. So it kind of chocks away, and I think finally we're ready to go. Started off in orbital mode, camera mode. I'm going to hit ground view mode, so we get a view as a ground observer, and let's give it a go. So I'm going to start the engine with W, and we're rolling, and there we are, we're off. And there it is. There's our plane flying, and I'm controlling it. Slightly clunky controlling it with keyboards, but obviously you can connect up a game controller if you want to, or a joystick of any sort. But there we go. Control inputs are varying the camber of those surfaces, and that's making the plane fly. Switch to orbital mode. So what, let's try and do some stunts. There we go, loop the loop. Let's try hammerhead roll. So we're going to go up till we stall, kick in the rudder. Kind of. There we go. And what else can we do? Oh, let's try flying upside down, see if that works. So some people say wings can't work upside down, but actually these wings have no problem flying upside down at all. So my pitch control is reversed, but my roll control is the same. The only thing that's different now is the dihedral means that once it starts side slipping, it tends to roll out of the turn, so it's a little harder to fly. But there we go, we're flying upside down. Let's get out of that. We're doing an outside loop. Just about getting round. And there we go. Let's lower the throttle. Let's go to FPV mode and see if we can bring it in for the landing. Coming into land. Say hi to Aeroman. Okay, that'll do. We're kind of on the runway. And there we go. We've done a successful test flight of our aircraft. And so what we've seen there is that you can put an aircraft together out of fairly simple bits. And there's nothing moving on here in terms of controls, but what we're doing is varying the aerodynamic camber of these surfaces to simulate a flight control surface. So we've got our ailerons by altering the camber of the wings, we've got pitch control, and we've got yaw control, and combined together we've got a fully serviceable flight vehicle. And coming up in the final tutorial in this series, what we're going to do is a bit of scrap heap challenge, and we're going to take this aircraft and redesign it as a novel configuration with the tail at the front and the engine at the back, and put all our principles into practice and get that flying.